Hello students. As you had so many of the doubts were in common, so I decided to have a proper doubt session, and it is a nice feeling also. Most of you have done quite a good job about it, and you are helping each other. Even if the solution is not up to the mark, there could be a small mistake, but your brain is really working, and mistakes are always proof of the fact that we are trying, and that is what counts. The first question that you asked me is question number 10. It says that you have two positive charges Q2 and Q3 fixed along the y-axis. Two positive charges Q2 and Q3 fixed along the y-axis. They exert a net electric force in the positive x direction on a charge Q1. Now this charge Q1 is not given to us as positive or negative. By error, you take it to be positive and end up at the wrong result. But it is definitely given to us that the net force acting on Q1 due to Q2 and Q3 is along the positive x-axis. For that, it must be that the two forces acting on Q1 due to Q2 and Q3 are equal in magnitude, because that is how these components will cancel each other and these components will add up. Thus, the force acting on Q2 and Q3 due to minus Q, the force acting on minus Q1 due to Q2 and Q3 is along the positive x-axis. Good deal. Now he says that if I add a charge plus Q over here at x0, then this charge plus Q will exert an attractive force on minus Q1. Thus, the net force acting on the charge Q1 is going to increase. I hope it is clear. The 14th question is one of the best questions in the subject and obviously the best one in the test. If you remember, कि आपका एक concept कितना सी कि if you have a few charges, if you have two charges placed in air and the force between them is F, then if you place the same charges in medium, then the separation between them is going to increase, decrease or remain the same. This was a question put forward in the class, and all of you agreed that the distance between the charges must be decreased, क्योंकि medium the factor ने force को घटा देना है, उन्हें equalize करने वास्ते we will have to decrease the separation between them, and the distance in medium was distance in air upon root k. If I think the reverse, that if r is the distance in medium, and the force exerted has a certain value, then what would be the distance in air? Air ਦੇ ਵਿੱਚ ਫਾਸਲਾ ਆਪਾਂ ਨੂੰ ਵਧਾਉਣਾ ਪਏਗਾ to give the same effect. Thus, if r is the distance in medium, then the equivalent distance in air is r into root k. बहुत clearly लिखा है. This means that if r is the distance in medium, then for the same effect, the distance in air is going to be r into root k. Think. Students पता ही करते हैं? They think that distance in air, बात तो ठीक है. The distance in air is the distance in medium into root k to have an equivalent effect. In this given problem, he says that you have two charges plus q and plus q, and they are at a distance, say 2r from each other. The force between them is F q square upon 4r square, given F. Now, he says that half of the distance between the two charges is filled with a medium. The theory that we discussed was the complete charges were in medium. Here, only a part of the distance between them is in medium. I hope you are following the question. Thus, the total separation between the charges is r in medium plus r in air. We have to equate both in air. If r is the distance in medium, then the distance in air is r into root k. K is given to us as 4. R into root 4 plus 4. The total distance between them is now 3r. It appears that the distance r in medium with dielectric and distance r in air is similar to a distance 3r in air. The total force between them will thus be given by q square by 9r square, which is 4f by 9. This was a doubt with most of you, and it should have been. You have to leave such questions. It is not necessary to do all of them, and we will always learn from some questions. Then you have question number 17. This was a simple one, but still a doubt of a few students. He says in this question that you have two positive ions each carrying a charge Q, separated by a distance d. The force of repulsion between the ions is F. What are the number of electrons missing? Q is equal to N into E. If N is the number of electrons missing from each ion, then the charge on each ion is N into E. Thus the force between them will be given by 1 by 4 pi epsilon naught Ne into Ne, which makes N square E square, and you can solve it. Question number 18. This is also a very interesting question. He says that 6 charges are placed at the vertices of a regular hexagon. The electric field on the line passing through point O and the perpendicular to the plane of the figure at a distance of x much greater than A from O is. This is the point where the field has been asked. On your plane of the paper, you will have a hexagon over here, and this would be the point where the field has been asked. We will have to assume that this arrangement is made up of 3 dipoles. Now, this is one dipole with dipole moment in this direction. The point O is not at the center of the hexagon, but it is here in this plane where I have marked over here. The electric field due to this dipole. Now, the point O, this is not the point, sorry. The point O is here. For the point O is lying on the equatorial line of all the 3 dipoles. This definitely should ring a bell, and this is a very interesting question. We know that the electric field on the equatorial line of an electric dipole is given by 1 over 4 pi epsilon naught 2p over r cube. Sorry, p upon r cube. Now, and the direction of the electric field on the equatorial line is opposite to the dipole moment. For this dipole, this is the direction of the dipole moment, and this is the direction of the field due to this dipole. For this dipole, this is the direction of the dipole moment, and this would be the direction of the field. For this dipole, this is the direction of the electric field, and this would be the direction of the electric field. This is the direction of the dipole moment, this is the direction of the electric field. These two fields are now at an angle of 120 to each other. If two fields are equal in magnitude and at an angle of 120 to each other, the net field will obviously be of the same value and will be along this, which makes this field as 2E. E net is twice of one field, which is kp by x cube, twice into 1 over 4 pi epsilon naught. The dipole moment is q into 2a upon x cube. Thus, the net electric field is going to be q into a upon pi epsilon naught into x cube. I hope it is clear. This is also an interesting one. Mogambo. Question number 19. You just have to do it with concentration. You have charges plus q at O, a charge of plus q at C, a charge of plus q at A, and the charges are shown. He says you have to find the force acting on the charge plus q at the origin. First of all, I observe that the charge plus q at A and the charge plus q at C are both positive, and the charge plus q at O is also positive. The force exerted by the charge at A and the charge at C on the charge at O will cancel each other. Hence, there is no need to really mark these two forces. So, in this diagram, I have marked the force on the charge plus Q due to minus Q as this. And this is the only force along the positive x-axis. Force along positive x-axis is the charge Q is here, Q and minus Q. This is an attractive force, which is Q square upon A square. Let's call it F. The force acting on this plus Q charge due to this minus Q charge is attractive, F. The force acting on this plus Q charge due to this plus Q charge is repulsive, but has the same magnitude. I call it F. We will resolve these two forces. These two components are going to cancel each other, and these two forces are going to add up. Thus, the net force along the negative x-axis is going to be 2F sine 30. Sine 30 is half, it's going to cancel out, and F, the single force F, is Q square upon A square. These two forces are equal and opposite, hence the net force acting on this plus Q charge is surely equal to 0. Thanda dimag. We just have 3 more questions left. Let me wrap the book. Boys and girls, I came for this lecture today so that we start with a new topic tomorrow. Tomorrow we are going to start with a very interesting topic, electric flux. Before we really start with electric flux, I will do a small thing with you, electric field lines. You are also advised to go through the same and write down the properties of electric field lines from the book. Now we come to question number 23rd. In question number 23rd, we have 3-point charges. The plus Q charge is placed at x is equal to 0, y is equal to A. Plus Q at a distance A. You have a charge minus 2Q at the origin, x0, y0, z0. In questions regarding the coordinate system, just go according to what the question is saying. You have a charge minus 2Q there. And you have a charge plus Q at x is equal to A. He says, what is the direction of the net dipole moment? This minus 2Q charge is going to be split up into 2. Minus Q for this dipole and minus Q for this dipole. This is also P, this is also P. Thus, P net is going to be P root 2 and it will be on this bisector. P net is P root 2 and P is given to us as Q into A. Thus Q into root 2 on the bisector. Ibrahim and so many other students had this query. We move on to question number 28. This is also an interesting one. He says the thin conducting ring of radius r is given a charge plus q. The total charge plus q is distributed on the ring. The electric field at the center O of the ring, due to the charge on the part AKB, is E. You are given that the electric field at the center of the ring, due to the charge on the ring AKB, positively charged. Now, before doing this question, let me ask you something. We all know that the electric field at the center of the ring is 0. Electric field at the center of the ring is 0. You are given that the electric field due to the portion AKB is E, and obviously this electric field will be in this direction. This positive charge would definitely have an electric field in this direction. Think. For the net electric field to be 0, then the electric field at the center due to the charge on the part ACDB, the electric field at the center pole due to the part ACDB has to be equal and opposite to E, because the net field has to be 0. Thus, the electric field due to ACDB is also E and will be along the line OK. Now you have question number 30. For question number 30, 2 point charges plus 2 coulomb and 6 coulomb repel each other with a force of 12 Newton. F is equal to K into 2 into 6 upon R square equal to 12 Newton given. If a charge of minus 4 coulomb is given to each of these charges, the new force is going to be F dash K. The 2 coulomb charge given a charge of minus 4 coulomb, charge is always additive. This would be minus 2 now. So one charge is minus 2 coulomb now, and the other charge is minus 4 plus 6. The first charge is actually, plus 2 minus 4 equal to minus 2, and now the charge is going to be plus 6 minus 4 is equal to plus 2. Thus the force between them will now be attractive, and it will be K into 2 into 2 over R square, which is going to be 4 newtons, because the value of K by R square is 1. That is why it was 12. Most of the doubts that you had asked me have been clear. If apart from this you still have a doubt, you can always put forth a query and any student will be able to do it. Question number 13 was also a very good question, but I had already formed a concept on that. If still there is a doubt, I would be too happy to solve it. Have a good night, sleep well, and we start with electric flux tomorrow. Good night.